Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna, for the nice introduction. Hello, everyone, and a very good and thank you for joining the session today. Welcome to AI for Good Machine and 5G Challenge webinar session. My name is Thomas Baskol from ITU, the International Telecommunications Union. The Machine Learning 5G Challenge aims to create a community to solve network-related problems using AI and machine learning. Today, I'm very excited to host another webinar, which is titled Machine Learning for SDN Security, Improving Intrusion and Vulnerability Detection. This webinar explores the current state of the art in SDN security and the role of machine learning in enhancing intrusion and vulnerability detection within software-defined networking environments. The webinar also launches the fourth problem statement of the 2023 challenge, which is titled Intrusion and Vulnerability Detection in Software-Defined Networks, SDN. By participating in this challenge, you acquire hands-on experience in developing machine learning models for detecting vulnerabilities and intrusion in SDNs, and also to deepen your understanding of the critical nature of SDN security. As always, we are counting on you, the participants who are joining the webinar today, to help create an engaging discussion. And if you have a question, please type them in the video wall, and we will take them during the Q&A session right after the talk. Without further ado, I would like to introduce the speaker of today's session. So today's webinar will be given by Evren Tuna, who is a 6G researcher at Ulak Communications based in Turkey. And he's also a PhD student in electrical and electronics engineering at Bahçeşehir University in Istanbul, Turkey. So welcome, Evren, and good afternoon. And thank you so much for making time to have this webinar.
Hello, Thomas. Thank you for this nice organization. I think I can share my screen now, right?
Yes, please go ahead, and the floor is all yours.
Okay, thank you. I think, oops, sorry. Yes, I think you are seeing the right screen, right?
Yes, yes.
Okay. So, hello everyone, this is Evren Tuna. First of all, this is my second time being the use case owner in this challenge. So I am happy to be part of this organization again. So we as Ulak Communication are glad to participate in ITU AI ML in 5G challenge. So today I am here to present you our use case, which is machine learning application for SDN security. And our aim is to detect the intrusions and vulnerabilities. So let's start. So Ulak Communication Incorporation was established in 2017 by Defense Industry Technologies Incorporation. And as Ulak Communication, our purpose is to conduct R&D and engineering activities for mobile and broadband communication systems by commercial network operators. So if you look at the pioneer time points of Ulak, we can say that we have a national product of Turkey, which is called as Ulak Base Station. This base station, Ulak Base Station solution is for the needs of civil security, public security, and military communication. And moreover, the Ulak Base Station is actively utilized by leading operators in Turkey at their commercial size. And in addition to this, also we have deployed base stations in rural areas. These are capable of run sharing between these different operators. And in addition to these base station products, we also offer software-defined wide area network, and also software-defined data center, so SD-WAN and SDDC. And also we offer SD security solution. And many institutions and organizations in Turkey use these products in their infrastructure. So in addition to today's studies and working, we also follow the future. With the help of experience from our existing products, we have provided significant advantages in the development of our 5G base stations. We also focus on the development of 5G and beyond. I mean that we are actively doing research on 6G. And also as Ulak, we are actively participating standardization activities like ORAN Alliance and open source manual. So let's take a brief look at our products. For the radio access network, we offer LTE advanced base station, 5G base station, and OAM solutions. And these products include BBUs and RRUs, which can operate in different frequency bands. In the core network also, we have the solutions of 5G core and evolved packet core in private LTE deployments. And for the SDN part, this is why we are here today, is we provide SD-WAN and SDDC products. Furthermore, we also focus on how to integrate our solutions and products onto the verticals. So this is very important for 5G and beyond networks. So that's a brief summary of Ulak. So today we focus on SDN, as you know. So let's start with an easy question: what the SDN is. SDN is an architecture designed to make the network more flexible and easier to manage. So by deploying SDN, we can centralize the management by abstracting the control plane from the data forwarding function in the discrete networking devices. So we can say that an SDN architecture delivers a centralized and programmable network. To better understand how SDN works, let's talk a little bit about the basic components of SDN. Firstly, we need a controller. This is the core element of an SDN architecture. It enables the centralized management and control, automation, and also policy enforcement. We have two types of APIs in addition to controllers: southbound APIs and northbound APIs. So both APIs can relay the information between the controller and the management of individual network devices or the applications and policy engines. So this is the general structure of an software-defined networking. Of course, I mentioned about centralizing something in the network, but in addition to this, SDN provides some advantages also. For example, by deploying SDN, we can configure network services in real time or quickly allocate the virtual resources to change the network infrastructure. So secondly, by deploying SDN, we enable the dynamic load balancing to manage the traffic flow. Thirdly, we can flexibly control the network, change configuration settings, and increase the network capacity. And one more thing is we can set policies from one central location, and it enables us to use the micro segmentation to reduce the complexity. So there are actually four primary types, let's say, of SDN. The first one is Open SDN. Here in Open SDN, open protocols are used to control the virtual and physical devices. Secondly, we have API SDN. By deploying an API SDN, let's say, we can control the flow of data and from each device. We have overlay model SDN, and it creates a virtual network above the existing hardware and provides tunnels containing the channels to data centers. And finally, we have a hybrid model SDN. By combining SDN and traditional networking, the hybrid model assigns the optimal protocol for each type of traffic. So we have mainly four types of SDN. So we can talk about SDN for hours, but let's briefly talk how our challenge topic emerged. With the SDN approach, we have developed software-defined wide area network to make these wide area networks more secure, easily manageable, and cost efficient. So I do not give the details of this product, but we have mainly 5 types of components in SD-WAN product. The first one is SDN controller. The other one is zero-touch provisioning server, big data platform, VH, and SD-WAN gateway. So you can see the name of Maya. This is the name of Ulak's product, and Maya SD-WAN product. So that's why we are writing Maya here. So in this slide, you can see the overall capabilities of our SD-WAN product. However, today we will focus on the security part of this product. So SDN solutions, okay, we will centralize some of the management part and some of the solutions, but SDN solutions come with a significant benefits, okay, but can pose a risk at the same time. The controller is very critical in that architecture, and we centralize it. So this is a potential single point of failure point. So that's why security notion is so important in SDN and our SD-WAN product also. So let's talk about a general overview of attacks and vulnerabilities in SDN. The first one is a compromised controller or application can gain access to network elements and directly they can manipulate the actions. The second one is the time for a packet from ingress to egress port of a switch gives information regarding the proactive or reactive installation of rules. This type of information then can be used to launch the DOS attacks. The third one is, I mean, maybe you heard about this, man-in-the-middle attacks are very popular in SDN field and also other fields also. That kind of an attack allows modification of processing rules by intermediate entities that can hijack or play havoc with the flows. And the fourth one is, since the third-party applications are integrated with the controller using the northbound APIs, any buggy, malicious, or compromised application can take control of the network. The fifth one is, this is the one of the easiest attacks on the SDN controller, DDoS, we call it like that. A lot of bogus packets are sent to the switch from an attacking host. So finally, we face with configuration issues. So policy consistency checking is very important in SDN. So let's talk about how today how we are solving the attack detection problems. So we have mainly 3 types of attack solving approaches, let's say. The first one is signature-based, the second one is behavior-based, and the other one is machine learning-based. So let's talk about for the signature-based. In signature-based attack detection, we monitor the incoming network traffic to identify the sequences and also patterns that match a specific attack signature. Of course, for each type of these attack detection mechanisms, we have advantages or disadvantages. So here you can easily see the disadvantages and also advantages of this type of attack detection. The second one is behavior-based. In this kind of attack detection, rather than searching for a specific pattern associated with a certain type of attack, we just monitor the behaviors that may be correlated with attacks. So the approach is different from the previous one. And the last one is, of course, I mean, we do not want only to reactive or we need to increase the accuracy. So we need, at the end of the day, we believe that we need machine learning. So in machine learning based attack detection, we just use machine learning. We train our design model with the previous network flow data. I mean, it may include the normal traffic or attack traffic. So before the attack happens or after the attack happens, we immediately want to take the precautions by detecting these attacks. But of course, as every machine learning problem, we may face that we need to design our machine learning model. I mean, we need a well-designed machine learning model. For example, if we are using a neural network model, we need to tune our hyperparameters well. And also, I mean, in a specific time interval, you train your machine learning model, but after time t, for example, the pattern may change because of the dynamic changes in the environment. So you need to update your trained model. So these are one of the most important points in the machine learning based applications. So let's look at the literature and also industry, that what kind of machine learning models are being applied to solve this problem. So we can see a lot of machine learning models that are applying to this field. So in supervised learning part, we can see KNN, DT, RF, NN, SV, bias theory, and hidden marker model. For the unsupervised model, K means self-organizing maps. And for reinforcement learning, we can see that some RL-based game theory approaches exist, and also deep reinforcement learning. And we can see some of the semi-supervised learning approaches also. So here, I would like to mention a little bit about some of the studies that I choose. If anyone interested in this research field, you can directly go from these references. So in the first three approaches, we can see the coarse-grained intrusion detection. Of course, different studies consider different types of features or feature sets. But here we can see that their classification target is the same. They just classify the traffic as normal or attack or anomaly, let's say. So we can see the decision tree, RF, HMM, and also SYM. So these are the approaches for that kind of coarse-grained intrusion. Oops, sorry. Yeah. Let's go on with the coarse-grained again. In addition to previous techniques, we can also see some bias net, decision table, and also deep neural network. Of course, someone can directly think that I should use the most advanced machine learning model or deep learning model, let's say, but it just depends on the problem complexity. So you need to take care of the trade-off between the complexity and also the computation part. We can also see fine-grained intrusion detection. Here, as you can see, the last two studies using more features than others. Of course, it depends on the design and what kind of feature extraction method you are using. But here, they increase the detail of the types of the traffic. Let's say the normal DOS, U2R, R2L, or probe. So again, the second study used SVIM and also RF. And after that, we can see the DDoS attack detection. And here, as you can see in the first study, they just use 6 features to classify the traffic as normal or DDoS. And in the second part, we have 5 classes. Actually, normal is the first class, and we have 4 types of separate DDoS classes. And in the third one here, as you can see, the deep neural network, they just use the 20 features. But if you look at the details of this study, they try different feature extraction methods. And of course, the number of features you use depends on your design. And here for the DOS attack detection, we can see 6 to 8 features and 8 classes. And also we can see some, more traditional approaches to solve this problem, machine learning approaches. And also for another study, Dean et al. Focused on the firewall performance optimization. And the last one, because of the technique that they used, seems more popular, I think, because, for example, in the first one, they used XGBoost. They use 41 features. They focus on 41 features, and they class the traffic as normal or DDoS. And in the last one, you can see 80 features. And also, I recommend you to look at the Canadian Institute for Cybersecurity. here you can access different kinds of data sets, and also by using these data sets, the guys over there published some papers and etc. So if anyone is willing to deeply dive in that area, I recommend them to go into that website. So I give a brief summary about this field and why we are here and why we choose that area. So now it is time to define our problem in this ITU AI/ML 5G challenge. So in our use case, we provide a data set that combines of a small portion of real users obtained from our SD1 environment with certain known data sets. So we combined. So this data set encompasses 4 primary types of samples. Of course, when you go into the details of this data set, you can see, tens of traffic flow types. But if we classify in a general manner, we can say that normal flow, DDoS flow, malware, and web-based. So here we expect from participants that they will utilize some machine learning techniques to develop an intrusion detection model based on the data set that we provide. So we provide some necessary measurements from the network, and we will share the data set as train and test. Here, if anyone is doing some solutions on our problem, you can envision that it is as being integrated with Ulak SDN platform. Okay, so the story begins from our product. So that's why today we are enhancing our problem statement. So our main aim is to draw the attention to this research area and highlight its importance. So this is the general overview of how our network data is gathered. So here you can see a network traffic is flowing through the data plane. Above this, we have an SDN controller, and the interaction is from the OpenFlow. And suppose that you have a data collector. Of course, you will have the data. We collected the data. You will apply a machine learning model in this ML module. And by training your model, you will classify the traffic type, whether it will be normal traffic or any DDoS attack or any different types of attacks in the network. So we have shared a time-labeled data set. We have a training part and validation part. Of course, as Ulak Communications, we have a different kind of data. Of course, we obtained this from the same data set that we shared with you, but the evaluation will be done through this data set. Totally, we have 79 features, and the outputs will be actually, you can see the 15 different types of network flow. So this will be a typical classification problem. The challenge teams will share their technical reports and codes with the Ulak challenge team. And the technical report is expected to be in the PDF format. And we expect from participants to explain their solution, including the outcomes of their models. As Ulak, we do not want to restrict the participants about a specific machine learning model or specific type of neural network model, etc. So, but we just want to explain. We just want you to explain why you choose that machine learning model, and from your perspective, by comparing with the baseline solutions, why did you choose and what is your advantage? So by deeply providing this kind of answers to us, and also of course the performance criteria, this would be accepted for Ulak. So I would like to mention that you select a machine learning model, but in your report we want you to compare this machine learning model with the popular 3 kinds of baseline models in the literature. So So, I mean, obtaining these results directly will answer us why did you choose this. So here, as you can see, the label details. You can see that lots of different types of traffic flows exist. So you will just classify these traffic labels by looking at totally 70 or 80 different types of features. Of course, we do not want you to use all of the features. Of course, you will apply some feature extraction techniques, but okay, you are free to use any one of that kind of extraction methods. We want to get the optimized solution. So let's look at the performance criteria. Actually, we will evaluate the performances of all solutions by this criteria. For example, we want a maximum of false positive value as 10%. Accuracy must be at least 90%. Recall and precision is the same. And also, we will evaluate the performance with k-fold cross-validation. Of course, suppose that two machine learning models produce the same results, same performance criteria. The thing that we will look at which one is more complex regarding the others. So we will, as I said, we are an industry, we are in the telecommunication industry. So as you can guess, we should merge both academical part or research part and development part together, because you can produce a very well designed model with a very good performance measurements, let's say. But at the end of the day, when you want to deploy it in a product, it should be in an optimized way of computation. So that's why we are giving importance to that criteria also. So we are not restricting you to use any kind of tools or APIs. For example, you are using LSTM, let's say, or RNN, you are free to use Keras, TensorFlow backend, and also PyTorch. You can use anything, any tool you can use, you are free. So if you look at the registration here, as the ITU AI for Good announced that we are already registering the participants. The submission deadline is 31st of August, and evaluation and grand challenge final is the, as you can see on the slide. So, of course, as Ulak, we are here. So we are together a team with Abdullah from, again, Ulak. He is also a network and systems engineer. He is deeply dealing with this SDN architecture, SDN deployments, etc. So in any time, the challenge participants may communicate with us through our emails or etc., LinkedIn, etc. So we would be glad to answer your questions. And of course, throughout this challenge, we will be in contact with you together with Abdullah. So these are all for me today. Thank you for listening. I hope that everything that we proposed today are clear to you.
Thanks a lot, Evren, for nicely introducing the webinar as well as the challenge that you have proposed this year. Thank you so much for making time and for convincing Ulak to be part of the ITU AI and Machine Learning 5G challenge. It's really nice. So this time around, we are going into the Q&A, the discussion. For everyone that is tuning in on the neural network, you can please post your questions on the video. Please type them, and we are going to take them during this Q&A as well as discussion. And of course, I would like to invite my colleague, Vishnu. Hi, Vishnu, good evening.
Hi, Thomas. Yeah, thanks, Evren. Excellent talk, as usual. I want to just briefly summarize what you have done. I think it's a classification problem, as you explained nicely. And also the one of I had, you already answered. There is a tool set, what kind of tool sets can be used. I think you already answered that. Then slide 31. Yeah, slide 31, you had baseline models. So can I ask you, has Ulak done some studies on the baseline models? What do you, first of all, what kind of baseline models? Are these generic baseline models that you're talking about in this slide? Or do you have baseline models that you have trained, which you would be comparing against? In general, what is your comment on the baseline models?
Okay, Vishnu, thanks for this nice question. Actually, this is the problem that today we are solving in a successive way. So, of course, I mean, I did not want to mention about the specific baseline model because, for example, suppose that you are applying a recurrent neural network. So you have a time series data set and you are just predicting the next time or next time interval. So in that kind of a neural network model, the typical baseline will be, I mean, the naive bias, just you are predicting the next time. Or for example, specific to this problem, you're proposing a new loss function. So, okay, if you have a new loss function and the same LSTM model, for example, you need to compare it with the traditional loss functions. So, I mean, whenever, I mean, which in the literature or industry, you can directly access the popular machine learning models, and they generally comparing that kind of models with the very popular baseline models. So I think it is not true, as far as I believe, that it's not true to restrict anyone. But I can say that, for example, convolutional neural network you are applying, you can directly use a typical or artificial neural network. Just you are applying some dense models, and you can see the differences between them. These are the things that I can say right now.
Cool. Yeah. Thanks, Evren. There are some questions from Rajesh. He's asking about feature extraction, which tool you have used. Actually, that's a good question. In your figure, which showed this SDN data flow underlay, and you were talking about data collection. I think that's a nice figure. And in that context, I think I believe this is a good question that he's asking. Feature extraction. What kind of tools have you used for the feature extraction?
Actually, from the literature part that I saw you in the slides, that there exists lots of different solutions to this problem. I mean, this is a very popular problem, but here, as you can remember, that the solutions, the number of the features that they are using is changing. That is because everyone is trying to apply different feature extraction models. So that's why, I mean, for example, we provide you nearly 80 features, but one can use 10 features and one can use 15 features. So this just depends on the user design. So again, you can use the popular feature extraction methods in the literature. So you are free to use any one of them. Of course, I mean, it would be better if you use the less number of features, because that directly decreases the input dataset size, and also it will have an impact on the computation load. So, but we do not want to restrict you.
Cool. Yeah. Real-time detection. Yeah. So that's another interesting question, especially because you are dealing with data plane. I believe that's an interesting question also when it comes to latency of the classification. So do you plan to do this in the what was the name? Maya, right? Maya frame. Yeah. The Maya framework. Will it do real-time detection? No, I'm just joking. What is your comment on the real-time detection as such? Actually, will such techniques apply it? Will such techniques perform well? Yeah, please go ahead.
Actually, this is a nice question, because this is the real popular phenomenon in telecommunication industry. okay, with thousands of papers, you can produce very well-designed ML machine learning models, deep learning models, etc. But when it comes to deploy it in a live network, it is where the story begins. So, of course, it is very important that the designed machine learning model is able to integrate with the live network or not. So at the end of the day, of course, after doing some offline, development of machine learning model, of course, at the end of the day, we are trying to integrate it on a live network. But of course, as you said, in this scope of this challenge, we do not planning to use it in a live network, but of course, it requires an additional effort. So maybe in the future of this challenge, maybe we can do it like that.
Sure, sure. Actually, the next one is also a very interesting question from Rajesh. Packet-based or flow-based? Actually, that's a very interesting question also. So in flow, do you, first of all, in your product or in your research, actually, generally in the research, does such classification problems use flow-based features at all, or is it no memory, zero memory, packet-based system? So what is your opinion on the two approaches, and would your solutions be based on flow-based or packet-based? I guess that's what is that.
Okay. Of course, it depends on from what point you are analyzing the problem, but I believe that flow-based ones have more potential to deploy in a live network. So that's my choice. But if any one of you can also design a well system model and also a good machine learning model that can perform better with the approach of packet-based, but I believe that flow-based.
So the data set, I believe Rajesh is also asking whether the data sets are flow-based or packet-based. Are the features okay?
Yeah, as you can see, we have 15 different types of traffic flow. One of them is normal, benign, it is labeled as, but the other one is the different types of different attacks or intrusions, let's say. So we have just one for normal flow and 14 of different other attack types.
Okay. So it is flow-based data that you have.
Yes.
Okay, cool. Okay. Sami is asking, should we reproduce the results from existing research to find baseline result? Oh, okay. Yeah, what do you think? Yeah.
Yeah, actually, in order to make your model more generalizable, we need to compare it with some well-known baselines. So you can use any one of baseline solutions in the literature, but of course it should be it should make sense for the general literature. So you can compare your solution with source-specific baseline models, but in the end of the day, I think it would be better if you use well-known baseline models.
Cool.
Because at the end of the day, we will gather different solutions. So we will evaluate. In order to finalize this process, we will also use some general well-known baseline models.
Yeah, actually, Sami, I think it is a good starting point from our past experience. If you are starting, then I think it's a good exercise actually to look at the baseline models, repeat the results first, and then look at building on top of it. I think Evren knows very well. He has been a judge. Actually, that's my next question, Evren. You have been a judge in this competition previously. What is a good submission? I mean, in general. I mean, not only for your problem statement.
Okay.
You have seen submissions. Some of them good, some of them average, some of them really good. And you have actually picked out good solutions as a judge. So from your experience as a judge, what would make you give the prize to the participant? So if I am a participant who's submitting a solution and you're the judge, so how should I, what should I do to get the prize?
Okay. So, I mean, the heart of this challenge, let's say, your solution, your performance metrics. And so the first thing that you should is you should design a well model, let's say. But of course, only designing a model itself is not enough, because you will you will send these solutions to the judges and also the use case owners, and we will have even tens of same solutions. I mean, solving the same problem. But the other second important thing is you should prepare your report very well, because I mean, sometimes that kind of tasks seems do not have any priority when we think about the machine learning model design, etc. But this is the thing, that the way that you tell your solution to anyone in the judges. So the report should be well prepared. And finally, of course, presentation, because it is the first step, that you provide your solution and you are trying to attract the people that you listening to. So three main criteria are important for this challenge.
Cool. Yeah, those are very important tips. I hope our participants are listening. Evren actually, as I told you, has a lot of experience doing this with us. I think data sets. So could you tell us a little bit more about the data sets, especially first of all, how big it is? Would we need participant need GPU, or can we use general purpose CPU? In your experience, how much training time do you think, according to your prediction? These are things which matters to the participants. Some of them don't have access to GPU. ITU gives free GPUs just in case anybody needs. They can write to us and we provide access to free GPUs. But Evren, what is your experience? What is your opinion about the data set? Yeah.
I think every participant will follow the same way, but I just want to repeat that. I mean, whenever you're faced with a new data set, the first thing to know that what are the features, what are the meaning of these features. For example, when you look at the data set, for example, you will see flow duration, total forwarded packets, the forward packet length, and also you will see some IAT mean times, bandwidth, flag counts, and you will see some also active time lengths where the packets are sending. So we provided nearly 80 different features, but of course, all of them nearly are are formed by some values. So typical regression, let's say. But you will just analyze what kind of a traffic flow has what kind of a value distribution. You will just train your model by using these metrics. But of course, before using, I want to repeat that you will need to extract the features, because maybe you will do some typical basic correlation heat map. You will prepare and you will determine a threshold value, and you can directly decrease the number of them. It depends on you which technique you use. Actually, I cannot say, I could not remember what was the exact name of rows, but millions of rows we provided as Ulak in this data set. But that's why we want you to evaluate your performance by k-fold cross-validation, because, for example, you can determine a small portion of a data set as train set. Okay, it has a specific pattern, but suppose that you train your model and we get the weights and architecture of this model as H5 file, let's say, and we will direct it to another different data set which has different traffic pattern. So your performance directly decreases. So that's why we want you to train your model with all the data set that we provided.
Okay, cool. Yeah. And the data set, is it simulated or is it a hybrid with simulated and real, or based on a test data set? What is the type of data set that you
actually a small portion of this data set is real data set, and other data sets, and the remaining part, let's say, are from public data sets from any platform that you can look. But I recommend participants, maybe if anyone is getting more interesting in that area, you can use Canadian Institute of Cybersecurity. They are providing well designed and produced data sets. For example,
actually,
in our today's implementation, for example, we just divide our data set as train set, for example, that just the 70%, and the remaining 20% is the validation, and the last one is test set. So we follow the same way, but we did some small modifications on the data set, so that's why it differs from the original public data set. So, but you can think that it is the combination of all of them.
Understood. Yeah. I think the Canadian data set is quite an interesting data set. Yes. I think you have mentioned this previously also.
Yeah.
It's quite an interesting data set. I want to ask you about paper submissions. Meanwhile, let me check if there is no other questions. Yeah. So paper submissions. You have been involved with us for ITU journal, Future and Evolving Technologies. ITU has a journal where we publish. I mean, just for the sake of participants, we have a special edition at the end of every challenge, and the papers from the challenge get published. If you are interested, they are published in the journal. I want to ask Evren, do you have plans for publishing, I mean, not only in ITU, I mean, anywhere else also, publishing papers based on this research? Would your team be interested in publishing the research based on the challenge?
Okay, actually, as I said, we are not new in this area. We have already took some steps in that area, and today we are actively solving this problem in our products. But of course, we would be pleased to publish paper, but it depends on the study or work. So, I mean, if possible, we can do it, but we should evaluate after the performance evaluation process, let's say. But we are open to that kind of things.
Understood. Yeah. So then, prizes. Of course, ITU gives prizes. Last year we gave out 1,000 Swiss francs for each problem statement winner. Along with certificates and so on. This year also we plan to do something similar. So if you would like to get richer by 1,000 Swiss francs or something similar, we have it on the table. Please please, I think this is a great opportunity to work with Evren and team. We will have, I think we will have further Q&A session. I mean, we call it roundtables with Evren and team. Evren, Abdullah, and the others who are here to answer your questions, whatever you might have later as well. I think that's all. We don't have any further questions. I would like to thank everyone for the time. This is a great opportunity for the participants, as I told you. The data set is here. The link is here in the neural networks, and Thomas is here. So yeah, thanks everyone for taking the time and answering all the questions. Back to you, Thomas.
Okay, thanks a lot. Thanks very much, Vishnu, for moderating the Q&A session and some discussion with Evren. I would also like to thank you, Evren, for making time to make the presentation, give a webinar, and describe the challenge that is with us this time around. So I would like to urge everyone to start registering. The link has been shared. The challenge is open for participation. So anyone is welcome to participate. Please compete and submit your solutions. We'll be looking forward to having your solutions. And of course, at ITU, we have prizes that we have arranged for competitors, for winners. We have 1,000 Swiss francs for the winner of the problem statement. We also have certificates for participation, but also for winners. So we'll be looking forward to having many people join the competition and the challenge in general. We also have other problem statements that are open, so you can join any of problem statement that is of interest to you. So at this time, I would also like to thank everyone who have joined this session. You can interact with us either on our Slack channel, but also we have the AI for Good page where you can see several programs that are there. Tomorrow we have another webinar. It's not related to the challenge, but it's just a webinar in general. So you can also participate, join what kind of technical details are included in our webinar tomorrow. So we look forward to your participation in the 2023 edition of the ITU AI and Machine 5G Challenge. And thank you for joining us. Have a good day. Bye.
Thank you. Bye-bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.